Cool, so as I said, this talk is about our observability blunders. Here you have me, I'm Joe Stephenson. I'm a principal software engineer at Akamai. And I've been working on storage for a few years now. And I mostly write in Golang, I write microservices, I do all that application development. That's fun. And occasionally I do some infra stuff. With me we have Rodney.
Hey, my name is Rodney. I'm a platform engineer on the platform engineering team. I work alongside Joel. And we also work on storage for the past couple of years as well at scale, so focus on the internal developer platform. Background experience around cloud, security, Kubernetes, bit of everything. So, yeah.
Cool. Sure. So we're going to talk about our blunders, but first let me give you a kind of background of what we're doing. So like 2 years ago, at Akamai, we wanted to build new object storage product, and it was a completely greenfield project. And basically every engineer knows a greenfield project is the time to take all the stuff you learn about from blogs and you read it or you see it at KubeCon and stuff it all in until your project explodes into complexity that doesn't really work. And this is what we did, and it did work. And one of those such projects that we chose was OpenTelemetry. Before we'd been using open tracing and we'd used like the Prometheus client libraries, and these worked quite well, but we're in the new age, we're going to use OpenTelemetry this time. And it worked really well for us. At the time when we started, we didn't really know what consumers we were going to use of this. Were we going to use Jaeger versus Tempo? Were we going to use VictoriaMetrics versus Prometheus? We weren't really sure. It doesn't really matter that much these days, but at the time it kind of did. So I think it was about PR number 4 in our repository, where we set up OpenTelemetry for our development environment. And with that, we basically were having our Golang microservices, of which there was probably one at the time, export metrics, and it exported traces. Didn't export logs. It still doesn't because the API didn't exist at the time, and I mean it's beta now. We just haven't bothered switching over. As well as that, like pretty shortly after PR number 4, we started in some CNCF projects, such as Envoy, you kind of have native support of exporting via OTel-y. So we switched over very quickly to using that. So that's kind of background. But Rodney's about to tell us like what we PR'd on in number 4 was very, very different from what we went into production. Like there was a whole iteration process for what was working in dev, and then very quickly we realized it didn't work at scale. So here's what we had to do.
Essentially we start off with the basic deployment platform here. All our microservices are going to the gateway. From the gateway, we are sending metrics to Prometheus, and we also got Jaeger for tracing. But we didn't have any ingestion for logging yet, so we're just using the debug exporter. Doing kubectl logs, being able to just check out what's going on at the moment. But everything was quite contained inside this cluster. And this was pretty easy and pretty quick to get started, as what Joe said early on. But as our requirements grew for the project, as things got more bigger, more services were coming in, we need to find a way to centralize our telemetry data in one location without, of course, kind of going into clusters and trying to figure out what's going on. And that led us to the second diagram here, which is now our current architecture, where all our microservices are being sent to a daemon set that's deployed, of course, on each node, and then from there, telemetry data is being sent to the internal gateway, and from there as well, we sent all our data over to our observability stack. You might have noticed that what we are using as consumers instead, we've got VictoriaMetrics instead of Prometheus now. We also are using Grafana Loki, which we didn't have before for logging. But for tracing now, we switched away from Jaeger to Tempo, and of course Grafana for light visualizations and alerting. And so that's what it looks like right now. Of course, not just one cluster, but we've got a lot of clusters for our storage service instead. We are stable, that's a good thing. But during the journey of this, we shot ourselves in the foot quite a lot, and I think that's what we're going to dive into next year to figure out, what we did.
Yeah, so it's good knowing our architecture, it's good knowing when we got there, but what were the blunders we made along the way? Here we have a graph It's showing the active time series as reported by VictoriaMetrics. And as you can see on the graph, it's like flat at 2 million time series, which isn't very many. And then something happens at 1625, where it goes from 2 million to near 40 million, very, very quickly. And our observability team came to us and said, hey guys, why did you just send us 38 million time series all at once? What are you guys doing? And we, of course, had no idea what we were doing. We didn't know why 38 million time series suddenly appeared in our VictoriaMetrics. But the one clue we did have is that something happened at 1625 that caused it, probably a release. So what did happen? And I'm going to give you kind of background on the Kubernetes attribute processor, which you may be able to figure out might have been the cause. So what is the Kubernetes attribute processor? In short, it adds Kubernetes metadata to your metrics and labels and logs and traces attributes. So yeah, let's go through our metric buckets created total, and you get this lovely attribute k8's pod IP, which is the IP of the pod that sends the metric. You get the container name, yeah, it's bucket creator. You get the namespace default, node name, node one, and the pod name and everything. It's all really useful. Definitely use this. But you can like do this all in the application level, but that would just be tedious, and if you're ever like running third-party stuff, it just wouldn't work. So this process is really good. Recommend using it. But where did the problem come in? So let me give you a kind of a bit more of a clue of how it works. So it has like this association concept where it maintains a list of associations, and it does it based on the pod IP that sends a metric. Is kind of like a key in a map or like an entry into a list. So if the rate limiter sends a metric to our OTel agent, in our association list we'll have like 10.4.2.4.13 is the rate limiter, and it'll like keep the metadata, like it was on this node, it was on this container, this namespace. And if bucket creator also sends a metric, it has another entry. And it's a different pod IP that sent your metrics, so you know your associations are different. And that's all good. It works really well. However, if you introduce Istio into the mix, things get a little bit trickier. We use Istio as our service mesh of choice. Unfortunately, we're not advanced enough to be using ambient mode yet. Hopefully soon. So we're using the sidecar model. And you might suddenly like see an issue that's going to occur. So yeah, the Istio sidecar is now receiving the metrics from the rate limiter and the bucket creator, and it's proxying them to the OTel agent. And the problem we have here is now this association like table, all of the IPs are the same. They're all coming from 1.2.7.0.06, and if you know about Istio, this is kind of a magical IP that it sends traffic on. And yeah, there's no way to differentiate between the rate limiter and the bucket creator at this point. And you're probably going to see where the problem's coming from. So here we have two metrics, or two time series, both buckets created total. And the top one is mostly correct. It's got the pod IP 127.0.6, like we just discussed. Like that's kind of annoying that it's not the real pod IP, but who cares? It's got the container name Istio proxy. Okay, that's still not really that correct. It's got the namespace default. Yeah, that's correct. Node name's correct. And the pod name's correct. Okay, the bucket creator sent that time series. Cool. But the second one is where we kind of spotted what was going on and how we suddenly sent 38 million time series all at once. And here, if you look at all of them, they're all correct, kind of, except for this pod name. We have this rate limiter that is sending this metric. And that's how we clocked that our like attributes were just being labeled all over the place. Because the rate limiter didn't ever send a metric called buckets created total. It doesn't know about the buckets. It doesn't record this metric. There was no way it got there. So what was happening was OpenTelemetry, like the agent, the attribute processor, was just choosing a random value in that list and then assigning that metadata to your metrics. And basically, for every single pod that was sending you metrics, you'd just have like that many time series be sent wherever your data was going. And there's easy ways to solve this. We solved this very quickly. We just took this all out of the service mesh. We took the OTel agents out of the service mesh. And then we used application level MTLS, and we solved it quite quickly because people were shouting at us. But there's a better way of solving it, which is actually you can handle the associations and what Instead of just using the pod IP, build this association list, you can choose what you want to map these associations. So that was blunder number one. Luckily, we didn't have to pay the cloud bill for 40 million time series, but that could have got expensive very quickly. So on to blunder number two.
Yeah, so as you probably noticed in the first diagram that we didn't have any ingesting for logging, and once we had that, we also overwhelmed the observability stack as well, not just from the metric side, but also from the logging side. Essentially, the team wasn't happy, but we started noticing as well a large number of timeouts in our logs, especially the gateway, which was a bit of a concern. But to address this, the team had introduced Kafka to manage them execute much more efficiently. So that did help address a lot of things. But also from our side as well, we also optimized our stream as well by sending less logs. That's one of the first things we need to do. Leveraging log mapping strategies and also reducing access logging, log rotation as well. And it was one of the things where it was like first it was the metrics, and then the next thing was like logging pods. And the team was like, hey, can you get something working? But it got there. But overall, that was the main thing from our logging side, but we did address a large number of things. But that came from the fact that we didn't have any kind of ingested in the first place to try to figure out how much data we're sending over. So when you switch that on, we didn't know how much we're sending over, and that's what happened. So that was blunder number two. And number three was we kind of had now an architecture up and running now, which is great. But we wanted to make sure we test out, its resiliency and performance of OpenTelemetry itself. We wanted to do this before we go into production, and we wanted to the issue was that we're having difficulty trying to predict the behavior under real-world conditions. Of course, risk of performance issues and failures in production. And of course, we didn't want any downtime and any poor user experience for this platform. So what we created, we wanted to break it to see if it could be much more resilient and performant. So we were leveraging, one of the solutions was to kind of do a lot of load testing and optimize, of course, CPU and memory limits based on the environment. And we leveraged Warp there. But its purpose for log testing, we found ourselves, being able to simulate real-world traffic and identify, potential bottlenecks. This uncovered a large number of issues that we saw way before we went into production, which is really great. And funny enough, this helped us actually address, our issue of going to essentially when you went to production. It was a smooth deployment. We didn't have any issues, I don't think.
I don't think we have any issues.
It was a pretty smooth deployment, but that was because we kind of intentionally broke a lot of things before. And I think the second thing as well, we did pretty a lot. I think we did quite a bit was chaos engineering. And that was just, of course, introduce failures to test system resilience. Just for example, just delete a node and see what happens. And we did identify a large number of issues, and not just for OpenTelemetry as well, but for other services as well. So that helped a lot to kind of build a lot of confidence around what we need to do and what we addressed a lot of issues based on what our findings, and it made us a bit more confident when it comes to actually incidents. We had a number of instances, but we're much more confident when it comes to dealing with those now. But that was another learning lesson. It was a bit painful because it was hey, we built this cool thing here, and now let's try to break it. And but we got there because now we have a very stable, environment. But
yeah. Cool. So on to the next blunder, and this is kind of a mistake we made at the design phase. We got really excited about OpenTelemetry. We were like, okay, perfect. Let's read all the blogs. And we had this idea of this is how you do OpenTelemetry. You export your metrics and your traces from your Golang service over OTel-y. And one of the things we thought was the correct way of doing OpenTelemetry was to use these kind of receivers, the kubelet stats receiver, which will give you metrics from your kubelet, the Kubernetes cluster receiver, which will give you your API server metrics, and your host metrics receiver, which will give you your node metrics. And of course, these are all metrics we want. Right? We're at KubeCon. You probably are running Kubernetes. If you're running Kubernetes without these metrics, I'm going to call you insane because you're going to have a problem and you'll never know what's going on. But I can tell you in production, actually, we're running none of these receivers. We tried to use the kubelet stats receiver. We kind of encountered this trivial problem. And under some time pressure, we were just like, well, why are we actually doing it this way? Why don't we just do what we were doing before? We already scraped stuff kind of outside of these things. So why aren't we just scraping the kubelet like we've done for years, or scraping the API server like we've done, or scraping the node exporter? And kind of my point here is that, well, one, there's no one way to do OpenTelemetry. Of course, that's a foolish idea. But also, kind of, you pick and choose what you want to use from this project. Figure out where the value is for your organization. There was no value for us using the kubelet stats receiver versus the kubelet at the time. So we just simply didn't, and we used what we knew. So yeah, OpenTelemetry has provided us a ton of value. We just needed to find out where that was from and focus our efforts on that. So next up, blunder number 4 or 5. I wasn't counting.
Yeah. Once we had everything up and running, I think as well, one of the main things was that we started noticing a lot of gaps in our telemetry data when we were trying to visualize things. And there would be gaps that would come down and come up again, come down and come up. We're trying to figure out what's going on. Upon inspection, we found out like the gateway kept on crashing. There were a lot of crash loops, backholes. And of course, we just noticed like, hey, this is not great because we need a way to have consistent data being sent over. And we realized, of course, during the load testing we were doing, it just came to the fact that the gateway got overwhelmed. It was a single pod instead, and from there, that downtime wasn't really helpful, especially the data loss, because we need a constant stream of telemetry data coming in. But we've dug into as well, like of course the documentation, and we also looked at the collector itself, and we found we can enable auto-scaling for the collector itself, and that was pretty cool because that resolved our issues immediately. It's pretty simple. Just enable the key value pair to true, set your minimum maximum replicas, and it's pretty cool because you could see like our gateways went from just being one pod, to about like 3 or 4, and if we did a load testing, there would be more pods to be generated. But if we didn't need those, just go back down to 0. Oh, 1. But it was pretty handy, and we started getting a constant stream of data, so that was pretty cool. But it was painful because we didn't realize what we needed to do from there, and it just came to the fact that we're worried about like data duplication as well. But that's why we kind of shifted everything into the agents and scrapers themselves. But that gateway, the gateway failure issues was resolved pretty smoothly by, of course, us just figuring out what we needed to do here. So, yeah.
Awesome.
And summarize, overall, we now have, I guess, a great observability experience. A lot of the experiences we were having were just like pretty much shooting ourselves in the foot, but overall, we have a good experience. I would say the deployment as well has been really good, starting from the basic one.
Yeah.
And even migrating over to a much more complicated one. But the customization part, I guess, was a smooth experience as well. It's very customizable. And big shout out to the community. That's a lot of the things that weren't really in documentation or we couldn't find, we could reach out to Slack or to get up issues. Also blog posts as well is really helpful. Pipelines are cool, being able to structure the data, how it flows from receivers, processors to exporters. That's pretty neat as well. Being able to choose the consumers that we needed to use, that was pretty great. We were doing a lot of trial and failure as well, or trial and error to be able to see if do we need to use Prometheus here, do we need to use VictoriaMetrics. So that was pretty neat to have like an extensive range of exporters that we could use. And also a wild instrumented collector. That was one thing. Monitoring artists, those are pretty cool dashboards that we were able to use, be able to monitor the collector itself whilst we're doing a lot of testing and trying to break things. I think another thing also we found really, really instrumental was the deployment patterns. So JP crawling, not sure if he may be here or not, but they're very, very cool list of deployment patterns that are there. Even the basic one was actually there. But it went from basic to using, of course, multi-cluster and also Kafka as well. So big shout out to JP Crowling. And
yeah, and on this slide, I say the bad, and there was maybe some bad parts, but as Rodney was saying, we mostly shot ourselves in the foot a lot. One of the ways we did that was we released into production before OTel went into its 1.0 phase, which is typically frowned upon, and that meant we had to deal with API changes. Typically, those API changes were for the better. And then, as well as this, like the documentation around how you move into production kind of wasn't there at the time. We've now gone back to actually check that it was not very good, and it's now much, much better. So hopefully, you're not going to experience this as well. And then similarly, I put down scalability issues, and you might all scream at that and go, oh, I'm never going to use this as scalability issues. But really, this was if you deploy it badly, you will get a bad result. So kind of now that there's the documentation there, there's the deployment patterns repo, which is really useful, and the community is really helpful. You can achieve a tremendous observability pipeline at an excellent scale with very few outages and very few observability engineers shouting at you. So yeah, that's our summary. We really enjoyed using OpenTelemetry. Would use it again in our new future projects, and we're definitely going to keep using it in this project. So thank you very much, everyone. Cool. We're happy for any questions, but we can mostly tell you what not to do, not necessarily what to do. Awesome.
Yeah, thank you. Nice talk. I have a question about auto-scaling. Imagine that you want to increase the number of gateways from 1 to 10. How does the load balancing works in that way? Like all of the metrics were going to one pod, and now they have to split in 10 pods. Yeah?
yeah.
How does it work?
I think if we go back to that earlier on,
Sorry.
So I guess you got the, you can also make adjustments. I think by default you're using the target CPU utilization percentages there. So I mean you can adjust based on what you need. If you need to reduce that or increase that, that's one of the ways that that will do the load balancing. But the HPA probably does this for us automatically.
Well, it depends on how you're sending your metrics to your thing. If you like, I don't know if you can do it over just like a HTTP 1 connection. Maybe you can. Then Kubernetes will load balance your service for you. However, if you're doing like gRPC, which I believe is what we're doing in our how we're sending our metrics, then you're looking at like your normal how do you load balance gRPC in a Kubernetes cluster, and that answer might be you do something bespoke of your application, or in our example, we use Istio to handle that load balancing for us. But it really depends, how you're sending those metrics traces or whatever to the agent.
Yeah. Thank you.
Cool. Okay.